So from last session, anyone have any doubt? From last session, anyone have any doubt? And did you try that homework? You didn't try? Chaliye, all right. So yesterday we covered that array data type and one second, yeah. So most of the data type. And today we'll go ahead and I will try to complete all the remaining data type. So some custom data type also will see and the requirement of those.
Share the screen.
Oh, screen is not shared, sorry. See my screen. All right.
Yes.
So let me go through. So yesterday we just covered this vectors of this STD logic, and then the attributes with and without attributes. So basically, these attribute will return the value, and the same will reflect while you are using the attributes. Okay, and for that integer also we see in the integer we have two options. Either we can go with the range and without range. So here without range and here with range. Okay, and you cannot go beyond range. If you go, then you will get the error named error with the named it is going overflow. Okay, so overflow, and this is the code which we saw yesterday. And next is the boolean. So boolean is just for the true false, that also we covered. Enumeration we also did. So this is kind of a user defined data type. You can define your own data type, and today we will see this. This is a powerful data type actually, and we'll see today in the custom data type how we can utilize this. Okay, and after that, yeah, so this is also the encoding, how encoding is happening, and how the red is coming as a default value, because it is encoded as 00, and 00 is the default value for this. Okay, and these are mainly used in the FSM purpose, FSM state purpose. Okay, and we saw the error data types also, so error is basic, sorry, array data type also. And array is nothing but the group of the same data type. Okay, yeah. So for this we just saw how the indexing is happening and how you can select a particular bit, I mean the part select, and how you can assign the value. So up to here we saw, and I gave you some homework also. Okay, second. Okay, Siva. So won't worry. So I just explained whatever we covered yesterday. I just explained. Okay. I hope you can link. And we are understanding the data types. We are understanding the data types. So if you know even the basics of data type, then you will be able to relate the session. All right. So can you please share the PPT? Yeah, you will get. No issue. You will get. Okay. So you will get. Actually, all right. So next is, let me go. So today we'll see mainly the uh, first we'll see the unconstrained constraint and unconstrained array, and then later on, why it's not coming. Then later on we'll go with the custom data type. And today I will try to finish the data type. Okay, today I will. What? Oh yes. So today I will try to finish the data types. Okay, so this was the code which we see yesterday. Okay, so let me go ahead. Just a second. Let me take my S pen. Yeah, sorry guys. So here, if you see in the array data type, so we are putting some constraint. Some constraint means, as you can see here, array is from 0 to 3. So this is nothing but the constraint, but we can go without constraint also. So without constraint means, can someone tell me what is this without constraint? Anyone have any idea? So constraint means basically some foundation you are putting, okay? With some condition, you are putting some conditions, and you can go without condition also. So for this array, we are putting in the range. We are putting in the range, the constraint. So we can go with the unconstrained array also. So let me go next data type as unconstrained array. So this is array data type. We can say unconstrained. Unconstrained array data type. So how, one second, let me remove this all. So how special they are? Unconstrained data types, unconstrained array data types. So this data type is same like array data type only, but array data type, but they are just without declaring the range and number of element in declaration. So basically, you will not give that range, okay? And also, these data type do not specify number of elements. Number of elements, and so these data types requires. So what is required basically here? So that element type should be there. Element type. So basically, you should provide data type element. Data type elements means you should. So basically, all must follow the single data type. So multiple data types are not allowed basically. Okay, and so you should provide the range also. So you should provide that range also, a range of that index. So which is how many element is not needed. So basically you should provide the number of element needs to be declared while signal declaration. So let me go with the syntax. Let me go with the syntax, and then we can see some examples, and we'll go with the code. So what is the syntax? So syntax is, let's say if you are writing type ABC is array of integer. So what is this? It's an array. If you see the last slide, so what is this? Type array is array, and then you are giving range of integer. Okay, so you are giving of integer. So array, but if you do not want to give that 0 to 3, that 0 to 3, so if you do not want to put that constraint, what you can do, you can just simply write integer range, and you can keep those bracket empty. You can keep those bracket as empty. So these bracket are indicating there is no constraint on the size. No constraint on the size. So let me show how we can declare the same. Okay. So how we can declare. So one second here. So we can declare like this, and if you want to declare some signal, it's a definition actually. And if you want to declare, so it's a kind of a definition. So it's kind of a define. Okay. And if you want to declare some new signal with the definition, so how you can declare that, guys? So basically, simply as we did yesterday, you can put just signal, and let's say sig underscore 1, then colon, and then you can put that type, which is ABC. And now you can give that range. So that range now you can give here from 0 to 7. So if you compare this signal with the previous signal, let's say this init array. So here I didn't give any range or any index. Why? Because that was already given in the uh, declaration when I was defining that. Okay. But now as this is unconstrained, so there is no the range is not defined at the time of this array definition. So that later I need to provide. So here you can see when I'm declaring a new signal, then I'm providing the range. And it could be any other also. Let's say signal and sig underscore 2. So we can have A, B, C, and we can give some different range. Actually 15 down to 0. So here you can see the beauty of this unconstrained array. You can vary the range as per your use. So basically, there is no constraint on the range at the time of new declaration of a signal. So you can vary this range. You can vary or you can declare that range. All right. So that's all. Oh, let me go through the comment. What the signal type here? So when you said here, so I have two line. Let's say this line number, I mean, so here you are asking here. So let's say this A and this is B. So in which you are asking? So you are asking where? In A or in B? When you said what's the data type, you can unmute and talk. Siva. Okay. So, oh, he commented. Uh, no. It's not like in this slide. It's line by line, man. So it's line by line. You cannot say in this slide or the previous slide. So you need to be specific. Okay. Okay. Let me go ahead one more time. So if I will talk about this part B, you still commented. Last two line has signal. Huh. So if I will talk about this line, so here, here, signal one is a signal, or you can understand this as a variable. Okay, variable which is of which is of ABC type, which is of ABC type. And when I said ABC type, so this is nothing but a data type, which is nothing but a data type. So because AC, which is nothing but a ABC is nothing but a user defined array data type. Okay, which is nothing but a user defined data type. User defined data type. So now does it answer your question? And if I will talk about this A, so here what is this ABC? So ABC is not a variable. ABC is a data is a new user defined data type data type which is an which is an not which is which is of integer type. I mean, it's an array of integer. It's an array of integer with unspecified length or range. It should be length. Okay, so uh, like that you should understand this A and B. And if I will talk about this second last, so this is also same. Signal 2 is, so here sig2 is a signal, that's a variable which is of ABC type. And what is this ABC? ABC is a user defined data type. Make sense? So shall we go ahead, Siva? It's clear? Or still you have doubt? So those the same thing I will show you in the code and we'll see the output, right? Okay. So let me talk about the assignment also. Let me talk about the assignment also. So if you're doing assignment, so let's say sig underscore 1 of 0, I can put any value because it's of integer type. So I can write, let's say 35. And sig of 2 of 15, 2 of 15, and I can put, let's say the value of minus 35 like that. If anyone have any doubt up to here, you can ask. Then we'll go with the code. All right. Chaliye, all right. If you are not having any doubt, so let me go ahead. And now we are having tool also. So as I promised, I will show you the net list also today. With the help of that, you can understand from starting to last. Okay. So what's happening? So here, oh, okay. So we should go with the new project, and we should do next. So what is the working directory for this project? Okay, it's using the same. What's the name of the project? So let's see the data type 01. So we are going with this. Let's see. So let's see. Oh, new project, open project. This one. Um, open project. Did I skip something? Let me create one more new. What's the name of this project? Data underscore type. Use existing project setting. Okay. Uh, already contain a project. If the project share same file and it made by that could have selected different directory. Oh, so empty create a new project by so here we should have that file name. Okay, the type should go with the next. Still, we are not having that file one. So anyone try this? Anyone tried this? One second, let me see. So we can have a file, right? Yeah, so I need to select this. Oh, okay. So we are having now VHDL.1, and here we should go with that library IEEE, okay, and we need to use IEEE dot std logic dot 11.11.64 dot all, okay, and you can go with the entity data type is entity data type is port. We can have a in std logic, and then we can have b we can have this b of as a out type of std. I mean, out is the direction, and the type could be logic, okay, and we can have end this entity, which is data type, okay. So now, if we'll go for the architecture behave of that data type is, then we'll see begin and behave of this, and we can have, let's say, b is having a value, right? So one second now. So now, okay, we are having this. Let me save this file, and and now we can just do run simulation tool. So we can just go here, and we can just click on the compile design, okay. Mm, so here, so is it compiled? You can see. So it's compiling, right? It's taking time. So this tool is just for mainly for the netlist purpose. I just want to show you once, okay? And later on you can use. Oh, maybe because it didn't use that wait statement, that's why it's taking time. Okay, so it will go till here. So here we can see full compilation was successful with zero errors. Now we can go Now we can go with the RTL simulation. Oh, so that simulation is not there. So what could be the reason? Let me check the other files. What was the location of that? No, guys. So it's 21st, right? So yeah. And I cannot. Oh, oh, and yeah, these are the application. So the startup is it installed. So let it install. Okay. So in the meantime, yeah, it's about to install. I'm coming. Let me connect the adapter. Okay, I'm coming. Guys. All right, guys. So let me do in parallel that our unsized, sorry, unconstrained array. Okay. So yesterday we saw this signal, right? And let me run the code. The tool selected. Yeah, it's selected. So let me run the code and let's see. Okay. So I can see it's a green, but are we using this array? We are not using, right? Okay. So now we'll see that unconstrained array. Yeah, here. So let me declare this type ABC is array and with the integer range, then this. Okay. So let's see. Now, what I can have, we can declare one more signal. Signal. Let's say, oh, it will be confusing if I will write int array unconstrained and all those things. So let's say if I'm writing simply A, signal A. Signal A is of ABC type, or it will be more confusing. Huh? So int again unconstrained array. So this is unconstrained array. Okay, and here this is of ABC data type. So I can put here ABC, and I can provide a range here. You can see here what we did ABC and the 0 down to 7. Then 0 to 7. Simply I can write. Now if I will go with this, so let's see if we can print. It's a default value. Let me check. So oh, I mean how I can show you this? How I can show? Huh? Okay, int unconditional array of 0, 0. Okay, and here also we can check for 0. So int unconditional array of that 0. Here can bit of ABC. So let's see. But this selection is not supported. So this selection. Mm, 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 mm. Then. Okay. So with the other way we can check basically. We can assign this value and we can check. So uh, 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 let me assign this way. So let me assign it to some integer data type which was I1. Okay, and we can check the value. So instead of this I1, what I can do, so int unconditional array of 0. Okay, that we have, and here I can write int unconditional array of that 0 is having value of, let's say, 7788. Let's see. Let's see. Oh, second. Uh, should be this. No. So it might be confusing. So I will show you the separate code. No worries. So here you can see the value which you are getting. Uh, Updated value. I1 is one second, guys. So initial value is this, and then right, init is 0. Perfect. Oh, so here I should put some delay also. So wait uh wait for 10 nanoseconds, right? So because I'm assigning, so I should use some delay. So now you can see the value is updated into 788, right? So here we understood how we can use that unconstrained array. But I agree, this is too massive, right? You cannot understand. I mean, it's a the huge. So we are putting lots of data type into one program. So let me write a separate program and we'll see. Okay, you will understand. And in the parallel, oh, it's done, right? So let me try this also one more time. RTL simulation. Let me check. Oh, it's still. So need to compile again. Oh, we got some error. What was that? This is the only path. Okay. Mhm. Why it is not selecting? Okay, so we'll see this separately. No issue. Should not come. Actually, I have model sim also. That's why it is coming. Again in the option, full path is Intel FPGA. Oh, Intel FPGA Lite. It is picking. I should go with the Intel FPGA. So this PC. Hmm. Now I understood. Huh? See, is in this I have to go. Yeah. Now I don't believe the issue will come. This path we need to select. And same I can put here. So because I have model sim also, it was taking path still bin 64. It is it's taking that path only. Intel FPGA Lite. It is taking that. So that's the issue. Should not take. Should not pick because our is this is the directory. Model sim Costa sim. Model sim it can take that. Okay, so I will check this separately why this is picking or it's pointing to the model sim because FPGA Lite is that model sim library. Okay, so maybe if you are not having that, so you should not get this error. Okay, so that we'll see separately. Totally all right. So let me write the separate example and we'll go ahead. We have to complete today those all the data types. Okay, totally all right. So what is next data type, guys? Entities. Okay, so let me go with next data type. So next data type is so I just want to mention here some existing data type, but how they are just created internally. So some standard VHDL data type. Example. So with the help of those enumeration data type only, they just created. Okay. So that we'll see. That we'll see. So the first data type is, you can understand, is type bit is 01. Type bit is 0, comma 1. 0, comma 1. And then type boolean. Type boolean is, we can have that false, comma true. So this we already discussed, but these are like how we are having those standard data type. So you can define even their own data type. So in that sense, we are discussing this. So now we are having type character. So in the sorry, yeah, we have that character, but in the character we can have, 256 of character. So you have to put the entire list as enumeration, so that you can do at your end if you want to define, because we are having 8 bit for the ASCII, and that every combination we need to define, basically that every combination. Okay, so that you can do at your end. I'm just simply writing all possible ASCII combination, so it will support those. So here you can just simply write all ASCII characters. So why I said 255? Because if you see the bit count which is required, for storing a character, so the count is 8, and with the 8 bit the possibility is from 0 to 255. So that's why. Okay, all characters. So this will be your character data type. So now next is the severity level. Next is the severity level. If you are from verification domain, and if you know the UVM, so you should be aware of this severity word. Okay, so yeah, severity level. So we can set this for some purpose. So we have, this is also a data type. So severity level is, and we can have different level. Let's say we are just giving a simple note. So basically it's a print message with some label, with some flag. If some message is coming with the flag note, so that means you do not need to worry, it's a simply note. But sometimes you can give some warning also. Sometimes you can give some warning also. So some display with the flag as a warning. Okay, and other than that, you can give error also. You can give error flag also, and you can give some failure flag also. So these are the possible severity levels which you can have. Okay, which you can have. Now, if I will discuss regarding one more data type, which is type STD, not logic, which is U logic, U logic is, and that is having U, comma, that is having X, comma, that is having 0, comma, that is having 1, all possible value, comma, that is having, so that is having Z and W. So weak low, weak high, and that unknown. Okay. So what is this? What is this? Sir, by mistake you wrote this std underscore u logic. Answer is no. std u logic and std logic both are different data type. So std logic and std u logic both are different data type. But std logic is subtype of std u logic data type. So what is this sub data type? That we need to discuss, that I will explain. Okay. So let me just show you these all things in the with the help of code. Okay. Chaliye, all right. Check in. So let me show you this in our code. So let me take a fresh code. So uh, yeah, let me remove this entity. We can have this as a data type only, or even we can change it to some particular array. Okay. Now we can have architecture, and which is behave of that data type. Data type is begin and behave and behave. Okay. So here let me use all the library IEEE dot numeric std dot all. Okay. And for the printing we can use this. I will explain later. So texture dot all. This is for the printing. Okay. So let's see. And here we can have this array also for better understanding. Array. There is type print of array. Or let me remove this node. Okay. Yeah. So now mm, it's having process begin and process. So we can have some variables and we can use them. So let's say I'm defining here. I'm defining here a type of, you can also tell, let's say int array is array and which is of 0 to 4. 0 to 4 of integer. Perfect. And here I can write signal my number is of int array type, and which is having value, some default value as we can have, let's say 10, 20, 30, 40, 50. So this is with initialized value. Now, if we'll go so if we'll go we can have a report. So report value at index 0 is having and integer image of my number of 2, sorry 0, my numbers of 0, and we can have here some delay also. Wait for 10 nanoseconds. Let's see. See, oh, typo. Yeah. So let me put here wait also. Okay. So can you see here we are getting value at index 0 is 10. So in the similar manner, we can write for any index. We can write for any index. So you can write and you can just change the index. So index 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. You can see. So you can see 10, 20, 30, 40, 50 you are getting. So anyone have any doubt in this, you can ask. So this is the perfect uh, declaration plus initialization plus that use or that consume of array type. So here I want to go with without constraint. So unconstrained. So I can put here natural range, and I can put like this. So which belongs to our unspecified or unconstrained array. So here you can see. So this is the indication of unconstrained array. Okay, but while you are declaring the signal at that time, you need to provide the range. So let's say 0 to 7. So you need to provide here 0 to 7, as you can see here. All right. So You need to provide here from 0 to 0 to 0 to 7. And then let's see. Uh, why are we getting error? Oh. So 120134. So let me give here 4. All right. So you can see here, this is the best example for unconstrained array also. So let me put this code in the comment section. You can try this at your end. You can play with this. You can play with this. Okay. So let me capture it here also. Yeah. All right. Let me go ahead. So now what is next? So next is this data type. Next is this data type. So we can check for the bit also. Type bit. So bit also. Okay. So let me take a data type. Let's say signal D1, which is of bit type. Okay. Which is of bit type. And I can put here B1 equal to that one. Yeah. So and we can have that also report value of D1 is. Then you can have so we need to get image of that bit and variable we can keep this as a B1. So let's see. And similarly, you can prepare any of the data type, and you can check that. You can check that. What's the error? Send. Oh, yeah. So you can see here for the B1 we are getting 1, right? So this is the bit. Similarly, you can do for this where we have this one. Similarly, you can do for this severity level and this character, this boolean, and all those, right? So anyone have any doubt up to here? Anyone have any doubt up to here? No? Chali, all right. So if you are not having any doubt, then we can go with okay. So we can go with next data type. So can someone tell me the next data type? You have any idea? Okay, or if you want, you can just declare this severity level also. Okay, so if you want, you can put this here. This is the type. Severity level is this, and we can have a signal here. Let's say some signal, and which is giving, let's say, the flag of the verbosity. Okay, so uh, let's say left let's say S level. So S level, okay. So S level, and which is of severity type, which is of severity type. All right, and default you can also give as a note. So let's see. Let's see. We can give report S level is S level is, and that severity level image of this S level. So let's see what it is giving. So you can see the default severity level is note. So you can change this also. Let's say if you want to change the severity level, so you can have severity level, you want to change it to error. So you will get the error. Alright guys, you will get the error. So you can see now severity level is error. Severity level is error. Clear? Alright. So now we can go with the next data type. So what is next? What is next to this? Chale, alright. So next data type is we will move towards custom data type. We'll move towards custom after the severity and all. And we'll see the subtype also. Okay. So we'll see subtype and custom. Let me go ahead. And today I will plan to finish. So let me go with the subdata type. So this is sub subtype is a data type in which you can understand. Let's say if I am writing subtype natural. So subtype natural. So I want to make natural is as a data type, but it will be sub data type under some other data type. Let's say an integer. In integer range, in integer range 0 to integers high. What is the meaning of this? So here natural will be a data type which can have value from 0 to 0 to uh, plus 2 to the power 31 minus 1 up to here. So you can have other type also. Let's say subtype is, let's say, positive. So what's this positive? Positive is integer and ranging from 1 to integer high. So here positive will be a data type. Positive will be a data type which can have value from 1 to 2 to the power 31 minus 1. All right? Make sense? All right. Now we can declare the signal also. Signal declaration with subtype. So it's a similar. So syntax is the data type only. Okay. So we can have a signal. Then we can have some signal name. Let's say natural. And we can have this natural. And also we can have signal positive. Sorry, this would not come. Yeah. Signal positive. And we can have this positive. Similarly, you should understand STD logic is a subtype of STD logic when I mention. And what is this integer high? So here high is the attribute which will return the highest value of integer. All right. Anyone have any doubt up to here? If you have, please ask. Anyone have any doubt up to here? Kesab, Siva, Vijay, anyone have any doubt? No doubt? All right. So let me show you the same. Let me show you the same in code. Okay. So let's take 1 minute break, guys. I'm just coming. Let me come back. So let's see that subtype in the code in the similar manner. Okay. So let me remove this all. Okay. So and this data type I can replace with sub. Okay. Keep it there now. So I can write here subtype, and let's say natural, and I want natural is that integer so here you can see the same I am following. Okay. And we need to give the range. So integer range 0 to integers high, and we can have subtype of positive. Positive is integer range from 1 to integer high. Integer high. I will also tell what's the benefit of having subtype. Okay. So what's the benefit of having this? So let me first declare the signal. Let's say signal some natural number which is of natural type, and some signal which is of positive number which is of positive type. So if this is a positive type, so let me give a negative number to a positive number. Okay, first, keep it simple. Let's say it's a 10, right? And the value of natural number is integer image of natural number, and let's say the same for positive. Okay, so positive. Now natural number, let me assign with 12. So let's see. So you can see the value of natural number and positive number is coming. Now let me give a not natural number and a not positive number to this variable. So let me give minus 12, and let me give 0 here. Let's see. So you can see here immediately you are getting an error. That is not a natural number. That's not a natural number. So when I said I will also explain what is the benefit of using subtype. So this is the benefit. By making subtype, you can make your debug easier, and you can prevent or you can avoid or you can reduce the chances of errors. Let's say you are getting some extra value, some under value. So by making subtype, you can prevent that. That's the benefit of having subtype. Make sense, guys? So I think yes. Now let's go ahead and see what is next. So next is we can have our custom subdata type also, and that's very useful actually. In our real design, that's very useful. So I can write here custom subdata type. Let's say if you want subtype which is of address line. So address line is integer which is a range of 0 to 255. मतलब हम अपने अकॉर्डिंग विड्थ भी डिसाइड कर सकते हैं. So here address line will be a variable. Here address line will be a data type which can have value from 0 to 255. This is also legal. Okay. And other example for this can be, so we can have, let's say, byte. So we can have this byte, and we can have from 0 to, or let's say that range, I mean, let's say we can, which is of STD logic vector 7 down to 0. So here byte will be a data type which can have value, or instead of this, what should I write? So which is 8-bit wide, which is 8-bit wide. So it can have 8-bit value. All right. And here we can have signal address and we can have signal byte. So this we can declare as byte type and this we can declare as address line. So guys, you tell me, for this should I go with the code or it's okay? No response? Okay. So let me show for this also the code. Okay, basic code. Let's say if I want subtype address line is integer range from 0 to 255. So here I can have signal address address line. So here I can write address equal to 128, and let's see, I can print the value. I can print the value. So value of address is address. Oh, again same mistake. Let's see. All right. Oh. We need to correct this. So natural number could be this. I'm intentionally giving this as a 0. Let's see for the positive. Let's see the error. Yes, we are getting. So we need to give that number as a positive number. Let's see. Okay. So we are getting 12, 10, and 128. If I will give this as a bit image, so what's your expectation, guys? It will give error or it will give last bit? Tell me. So you can see. So these type compatibility I will discuss later. No worries. Okay. So these I will discuss later. Now what is next? So similarly, this byte also you can cover. Okay. So now we have some standard VHDL data type based upon this subcategory. Sorry, subtype. We can have uh, 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 standard VHDL array data type. Okay. So what all we have? Let's see. So we can have array. Sorry. So okay. So all the standard signal I was discussing. So we can have this type and string. So string is a data type in VHDL, which is standard data type. Okay. So how that defined that we are seeing here. So is array and it's sorry, it's having a positive range, which is not defined. So it's unconstrained of character. So this is basically collection of all the data types, and by which we are having the standard data type. Similarly, we have next data type is type and Boolean vector. So VHDL is not case sensitive. You can write either in caps or in small or mixed, doesn't matter. So Boolean vector is array which is having a natural natural range of having this and of Boolean type. Other than that, we are having as a type bit vector is array, and we can have natural range. Natural range, and that should be of bit type. Similarly, you can have integer vector also and many more types. Integer vector is array, and you can have your own user defined data type also in the similar way. So natural range, natural range of integer. Okay, you can have your own. Now, how you will declare the signal? So in the similar manner, you can declare that's a signal, and you can have signal of uh, character array. Character array. So that can be of a string type, and because you declare that string as unconstrained array, so you need to give the range. So the range could be like 1 to 10. You can give like that. And similarly, you can have rest of the signal like signal sig underscore boolean array. It will be long. So let's say bool array. So we can have boolean vector that can have 7 down to 0. Why? So that you need to give the natural range. Similarly, you can have for the bit array, for the sig of bit array, we can have bit vector 15 down to 8. 15 down to 8. We can have like that. It's not mandatory every time you will go with 0. As I mentioned, it can be n down to m. So anyone have any doubt up to here, you can ask. Anyone have any doubt? Now, if we'll talk about the assignment. So how we can do the assignment? So let's say sig of character of array. So you can opt any index. You can opt any index, let's say 1. And in that, you can put any string. Any string like h. You can put like this. You can put like this. All right. So similarly for rest, it will be the same. So anyone have any doubt up to here? Can you ask? So shall we go ahead? Now we are almost at the last stage. Okay. Uh, so let me show this in the code. So if I will declare a signal. I will declare a signal as message, and message of string type. As I mentioned, we can have a string, and a string is having, let's say, 1 to 11. So what I can do, I can put any string here. That's a message, and message can have the value, let's say hello. Okay, let's say hello. Now if you want to check that value, so what you can have is report value of message is, and that message. Let's see. Uh, uh, 1 second. So, okay. Okay. So 1, 2, 3, 4, 5. I should take as it is. Let's say 5. Yeah. So you can see here, value message is hello. You are getting hello. Okay. That's all. Now similarly, you can deal with the other these types. So anyone have any doubt up to here? Can we go ahead? No response? So now finally, what we can conclude, we are about to finish. We are left only with one data type. So we can have our we can define some custom data type and custom array data type. So we can define custom data type. And so we'll see, for example, let's say type is, let's say, traffic light is red, yellow, green. So there is nothing new in this, but with the help of this, I will go and I will develop more data types. Okay. So we can define custom array data type also, which is nothing but we can have type traffic light group is array which can have a natural range which is not having any constraint, and that is of traffic light type. So you can see I utilize this custom and I made an array. I made an array. So how can I declare such signal? For the declaring a signal, simply I should write any signal of, let's say, some four-way traffic light. So that can have traffic light group, which can go from 1 to 4. So basically, it's nothing but you are making your own data type, which is of enum type. Then you are making an array where you are not putting any constraint. So that could be of unconstrained array. And after that, you are declaring that signal also. After that, you are declaring that signal also. So which is of having range from 1 to 4. Now we'll talk about this assignment also. So how you can assign the value? So you can assign the value simply. So sig four-way TL, sig four-way TL. In this, because it's an array, so you need to opt the range, let's say 1 to 3, and you are assigning the value. So it can have any value from red, yellow, and green. So let's say if you are giving a red, and similarly sig 4-way TL of 4, and if you are giving the green, so now from 1 to 3 all will have the red value, and the fourth will have the green. That's all. Let's see the same in code. Let's see. So here, what you can declare, guys, you can declare your own type. Let's say type traffic light is red, yellow, green. Okay, red, yellow, and green. So what is this? This is just basically traffic light. Now you can make traffic light group. Traffic light group is array natural range with no constraint of traffic light. So now you are having traffic light group. You can declare just a signal sig four-way traffic light is of traffic light group and having range from 1 to 4. Okay, now you can just assign the values. So or before that, you can even print the default value. You can even print the default value. So what will be the default value here? And let's see the report value of signal of 4-way of traffic light of 0 0 0 0 6. Okay, so oh, no, 0 is not there. So first, and so is, and this itself. Let's see. So let's see what you are expecting. Should come as red default value, right? Oh, 1 second, ma'am. Operator. Uh, so traffic should be of uh, let's see. Yeah. So here we can see we are getting red. Okay, and let me cover this. So let me cover this for 1, 2, 3, and 4. 2, 3, and 4. And let me print this 1, 2, 3, and 4. But after assigning some value. So let's say sig 4-way TL of 0 to 3 is having that red, and sig 4-way 4-way TL of 4 is having green. Or instead of this, let me put yellow. Let's see. Uh, uh, uh. Oh, oh. Second man. 0, 0, 1. Oh, sorry. What did you? Okay. So, okay. So this assignment also. Either, oh, okay, we need to provide 3. So let it do 1 by 1 only. So 1, 2, 3. Mm, yeah. Yep. Let's see. All right. So here we have the clear picture of green, yellow, red, green, yellow, red, green. And before that, all are having red. This is the custom. This is the customization which a user can do to develop anything. So if anyone have any doubt, you can ask. If anyone have any doubt, you can ask. If no, you may leave the call. All right. All right. Thank you, everyone.